Hello everyone. I've recently been working on an upgraded technique for creating animations using Stable Diffusion from scratch. This is no image to image on sprite sheets or existing videos. These are from scratch animations that I've been generating, and this new technique is a lot less time consuming than the previous one. The last one was a lot of manual effort, versus this one is a lot more automated and just requires you to set up a few things and then you hit render and it makes the animations. And for the amount of effort that put in, I'm fairly happy with the results that you can see on screen. The lady, which is my character, is something that I made during my testing, and then this orc character is something that I made during the tutorial of this video. So if you want to learn how this technique works and how you can do it yourself, then continue watching. So before we move on to a step-by-step tutorial, I wanted to give a quick overview of how this method works and what's happening under the hood. So to start off with, we're using a turntable image, and this is a reference point used throughout the entire process. You make this one time at the beginning for each character that you want to run through the process, and every time we run images through Stable Diffusion, this turntable image is appended to the left of it and is used as a guide for Stable Diffusion to say, this is how I want the character to look like, this is the kind of features and stuff that are going on, and really helps increase the coherency between images. Next, we have the source image. We need to make one of these per group. The animation you saw previously had 3 different groups in it for forward, sideways, and backwards. So for that, you had to make 3 source images. And these poses I have given with the project, so you don't need to make these yourself, although you can make your own if you want to. But then you also need to split this up and have these different limbs, and this is where the Exodia name comes from. And you need to create these different components for this pose. And another key thing to note is that the source pose also needs to have a JSON for where all these points are. So you need to make one turntable image per animation, like sheet. You need to make 3 source images and split those 3 source images up. And then you have your target poses. And once again, we have the JSON for the target poses as well as the images. So you can see here's 21 different animation, 20 for a run and 1 idle. And then the crux of the algorithm is the source to target morphing. So on the very left, you can see this arm, and the red line is that source JSON points. And then the blue line is our target, and we see the upper arm and the forearm are morphed along that. We have some interpolation on the elbow, and then we have this output here. And we do that for all the limbs for the body, and this is what the result looks like. And we take this and we run it through Stable Diffusion, and we get something like this out. Now, one last thing to note is that for the front and back morphs, it ends up being a little bit weird because of the morphing. We don't get right the information since there's no depth added to the JSON for where these points are. And so things are a little bit weird. And to get it right, you have to pass a very high denoising strength into Stable Diffusion, which gets it to look better, but then the issue is when you get to higher denoising strengths, all your images within and your frames within your animation start looking different from each other because the AI is hallucinating in different details. So the technique that I deployed was to use this median imaging approach, where I take that input components morphs and I send it through multiple times at fairly high denoising strengths. And each one looks, a little different from each other, but then I take all of those images and I take the median image, so you can kind of think of it as the average of all the runs, and I put it together into one image, and then I run that through Stable Diffusion at a lower denoising strength and kind of clean it up. And you get a lot more consistent results that look a lot cleaner at the end of it. The first thing you'll want to do is head over to the GitHub page. Now, I went through and I made an entire written tutorial on how to do all this stuff. So if you're looking at this later and you're like, well, what did I have to name this file, or where do I do everything? Everything's on here, so you can just follow on this, and we'll be doing the tutorial from this. So we're just following this step by step, and I'll show you exactly how to do it. You'll also need to go ahead and install your Python packages. The two main ones are OpenCVPython and NumPy. The rembg, I wrote a little note here, if you're later than 3.9, Python 3.9, you'll need to use a 3.9 or previous to install rembg, but you can use a 3.10 or 3.11 with these packages to actually run the stuff. We just need rembg installed somehow on your machine because we're interacting it with through the command line. The next thing you'll want to do is you want to clone the repo, so you can either download a zip or you can grab this here and open a command line, and we can git clone the repository, and now we have it locally. So if we head in, I'm just going to open up the README so we can look at this in here. And the first thing that we want to do is we want to create a workspace. And for this, what we're going to want to do is go ahead and just copy this template folder. So you copy it over, you can rename it to whatever you want. So in this instance, we're making it orc. I'm going to call it orc so it's easy to find. If you head in, you should see these two folders in file. And this is all the standard pose information that I'm giving with you here. You can make your own. You have to be a little careful with some of these that you make them correctly, but these should be good enough for most people. Heading back to the README, once we've created this folder, we need to tell settings.py where our folders is. So if we open up settings.py, at the very top, it currently points to this template, so we need to point it to orc. And we need to save this file, and now settings.py knows, and all of our programs know where to look and where our workspace is. So the next step is to create a turntable. And we need to make this turntable image, which will be called turntable image.png. And this needs to follow the pose that we have over here in the root here. So this will be our reference. And it's important to spend your time and make sure this is clean and what you want, because everything else that we're doing will be built on top of this. This will be in every single image that we generate as a reference, and we'll be deriving everything else from it. Now I've taken a little bit of time to go ahead and make one that I'm happy with. So I've gone in here, I have a control net open pose. With no preprocessor, we enable low VRAM, you throw in this pose from the templates that we've copied over, and then you just make whatever you want. I did some inpainting, and this is what I'm happy. So heading back to the README, this needs to go in the root next to that turntable pose.png right next to it, and we name it turntable image.png. So we're going to save image and head over to repo, Exodia, to the orc, and we name that turntable-image.png. Next, we need to create a source, and from this all the way down to until we do the sprite sheet right before it, all of this that I've highlighted here, we need to do this for every animation folder. So if we actually take a look in this anims, we have three different folders here, srun, frun, and brun, for side run, front run, and back run. And within here, we have all of our poses, as long with the settings that we'll go over later. But this is sort of what tells it, this is the animation that we want to do. And for each one of these, we need to make a source reference image, which is what we will be doing right now. So the first step is to, first of all, want to get within our folders. So that's the SD Exodia. And we want to call Python, as one too far forward, we need to do the Python prep. And this is the thing, is that moving in here, I did this wrong, you need to also provide an animation name. So to start off with, we're going to do the side run. So we're going to pass in srun. So you need to add this little srun to the end of your command. And all of these, you're going to be adding that srun to the end too. Now that it's done, if we head back here, you can see that there's a temp folder that just got made. If we go in, we see an srun folder, and we have these three new files in here. We get this image, which is what we're expected to create the source within. We have the pose, so we can see the pose that we're trying to get this new extra character in, and we have a stripped version, which will be a good utility for us. So I'm going to head over to Krita. You can use something like Photoshop if you want to. I enjoy Krita because it's a nice open source Photoshop-like. That's what I've been using. So I'm going to just dump these 3 files into here. I'm going to set properties to 20% opacity on that. Bring this over. Now, we're going to do a little bit of mangling. So most of this is fairly aligned because I set it up to be aligned like this guy, but we still need to move the arms and the legs. So this orange one is the right arm and the green is the left arm. So this one needs to be on the front on the right and this needs to be back on the left. And then this blue one is the left leg. The way I'm going to be doing this is I'm going to be coming into here. We're going to simply cut out the arm. And we will copy paste that into a new layer. And just, it's the wrong way around. So we have the right arm at the front here. We're going to get this in place. We're going to erase a little bit here. And then I'm going to just simply copy paste the entire layer. We're going to move it over here. We're going to shrink it a little bit just so it's smaller since it's behind. Now we're going to move it below. Now I'm just moving all of the limbs towards our target pose that we're trying to get for this source, and then we're throwing it into Stable Diffusion, and we're just running through until we're happy with the result. Okay, so I now have a image that I'm fairly happy with. So we're going to head over to here, and with creating the source, we need to put it within that temp next to image.png and call it source.png. Let's go ahead and save this image as in temps srun right next to this, image. We call it source.png. We throw it in, and then we can move on to creating components. So we can do a Python split srun, and with a split source run.py, it will go through, and if we head back to our root and go into comps and go into srun, we should see these 2 new files in here, the source image and the source image stripped. So this has extracted the thing that we made, and this has removed the background. And now we have the last little bit of manual work for the srun, and that is to split out the limbs manually. So we load in the image, we load in our pose, crank this back here, and what I'm going to do is I'm going to go through and I'm going to extract each of the limbs into a separate layer, and then we're going to save them out image by image. Okay, so now I have all of my different body components extracted out, and that means that we can now move on to actually rendering out an animation. So the first thing that we're going to want to do is we need to set up our settings properly. So we head into render.py at the beginning at the top here. We have this information, which currently is on my previous one, and we need to bring in all of that information. So I'm just going to be copying from my Stable Diffusion workspace, and we're just going to be replacing this character description, which gets put within this positive prompt. This is what I've been using, and as well as the negative prompt. And so this is what it will be using. The other thing to know is that we have the default prompt here, which gets run on everything. But then for this initial render, if we head back into the root of our workspace and over to anims and the srun, we have the settings.json here, which describes how it does. So this has the ordering of what body part it puts in front of the others, like what order they do it. So this gets put down first, and this gets overlaid on top in this order. Which way the arms and the legs, whether it puts the lower or the upper sections first or last. And then we have our run here, which goes through. And so for the side run, we have a single Stable Diffusion run with a denoising strength of 0.1 and 40 steps. And then we have a face, which just does the face. And we have a denoising strength of 0.4, and that is wrong. It should be a denoising strength of 0.1 and steps of 40. That should be fixed by the time y'all see the video. And then we can Python render.py srun. And now this will go through and open up, which should see, there we go, that's Stable Diffusion, and is going through and rendering us this entire thing. So it runs and it takes those components and it will splice together an image. We can actually see that in the temp section. We can see here how it splices this image together and creates this combined image. And then this is how the output looks. And this is another spliced image. And well, this is the output. And then we have another spliced image here. You can see how it pulls these limbs together. And then this is what the output looks like. And of course, if you head over to the renders and this srun, you can see the clean output of everything at the end here. So I'm going to let this go through, and once this is done, I'll catch back up with you guys. So it's finished up now, and we have this whole animation, which is decent results. It's not the cleanest, but for how little effort put in, it's a decent start. But there's actually something more that we can do, and that is with this iterate. So we can take that and in this iterate.py, which we have instructions here. So we have tooling to iterate on this and to bring in more animations before and after, and to really bring in that context and allow you to create these more smooth animations that are a little cleaner. And so we need to change the settings in iterate.py, some of them. Specifically, this image is left and image is right. So I have a decent PC. I have a 3080. So I'm going to crank up these settings a little bit. If you don't have as much VRAM, you might not be able to go as high because you're increasing the size of the image that you're trying to run through. So each one of these images adds 512 width with 512 height as always. And then we have the run here, which is the settings that it will use to run through. So we're running a 0.15 denoising strength with steps 40, and we're running through the face again with 0.1 and 40. So we're going to do Python iterate.py and pass in the srun. And I was going to go through and iterate. So the iterate has finished up. It took just over 6.5 minutes to run through and to run them all. So if we take a look, the results are a little bit more polished, a little better looking, and for how little effort we put in, it's a pretty decent result. So this srun thing, this srun animation is now done for now. So we can move on and we can start all the way at the top and do this for the back run and the frun. So that's what I'm going to go do now. So we're going to head over and we need to call Python prep source. We're going to do frun. And now if we head over to the temp folder, we see the frun. We have these in here, so open up a new document, throw these in, and just like before, I will be going through and putting the character in the pose that we want, this target pose, and running it through Stable Diffusion and splitting it up, and once I'm done with that, I will catch up again. Okay, so went through and I made all of the components for the front run, and now we're ready to run through another render sequence for this. Now, something that I do with the front run is a little bit different in the settings. So if we head over to Atoms, Front Run, and the settings of JSON, you can see that I have a new type in the run called a median, which this one, what it does is it generates, in this case, 9 different images at these settings, and then it will actually take the median pixel value between all of the images per pixel. Simply because when you do the fronts, the images and the components, they warp a lot. So we want to run with a high denoising strength, but we don't want it to, hallucinate in certain details that we don't want. So we run it a few times and we take the median value, which is sort of like the average of the images. And this helps things a lot. So if we run the Python render.py frun, it's going to go and it's going to start running through. But because we are running this median at a fairly high denoising strength and 9 times per animation image, this will take a little while to run. So I'm just going to let this go run, grab a cup of coffee, and, come back when it's ready. So I'm back now. Forgot to mention this, the original render took about 18.5 minutes, and the iteration on that took about 7 minutes. And if we take a look at the results, they're a little bit cleaner. And while this doesn't look the best right now, full screen, once I get this into the engine and some interpolations, it's gonna look a lot smoother in the animations. So now all that we have left is the final one. So it's a Python prep for a back run. And I'm going to go through and do the whole thing one more time. So I've made the last component section, and before we run it, let's take another peek into the settings for the back run. And this one looks very similar to the front run, but we actually do a bit more with the median. Compared to this one, we had a 0.2 with 9. Over here, we do a 0.25 with 15, simply because there's more warping, more weird stuff that we're trying to get rid of. And so I'm going to run this, and this is going to take even longer than the previous one. Render.py brun. So I'm going to hit go, and I'm going to grab some lunch, and I'll be back with you guys when this is finished. So the last little bit ran, and so it took about almost 32 minutes to do the initial render just because we were running so many median images, and another 6.5 minutes to do a second iteration on top of that. And the results are a little wonky in some places, but once we have this thing downsized and interpolated, then it's going to be a lot more difficult to see those differences and changes. So speaking of which, now we can, once we have all 3 done, we can go ahead and make the sprite sheet. So there's a few settings in here. The first one is to restrip, because we're stripping the background. The setting, if you set it to true, it'll always regenerate them. This is set to false, which is the default. If it's already stripped the background for something, it won't redo it. So if you end up changing the images you want to do, you'll have to set this to true or delete the images. Then we come to this atoms to join, and this is the folders that it's going to run over. So if we take a look in here in the renders folder, that's where it's looking. So we have those 3, and those are the 3 that we want to run. And the do all we want to set to false because we don't want to do everything in this folder. We just want to do these images in here. We don't want to look at any of these other images in this folder. It will dynamically then grab you this latest iteration. So it'll figure out, oh, iter 001 was the last one that you ran. so we're only going to use those. This would all be ready to go and set up to run. However, I like to do interpolation. So when we switch this over to the second setting, we have different folders. So we have an idle folder. This is to keep the things clean and not have the idle in the interpolation. And then we have the 3 different folders with a different folder ending now within this interp. We also have this do all, which means that every single image file within this folder is going to get interpolated, not just the ones with the right patterns and the latest iterations. So let's go through and actually run them. So we're going to start off with a side. We're going to come into here, we're going to grab our images that we want to do. We're going to make a new folder called srun extracted. This is not super important. You just need to make a new folder for the stuff that I'm using. And the other thing is to make sure to copy your first image and rename it so it goes to the very bottom. This is because our animation wants to loop, so when we're interpolating between this will actually get some endings so we don't have a jump through our thing. Now I use FlowFrame's video interpolator. That's what I've been experimenting with recently, and I've been really enjoying the usability and the quality. So we're going to browse for our folder. We're going to come into here. We're going to come into our workspace, our renders, and we're going to select this extracted folder. It wants to pull the folder into here, so I actually pull it out a folder. Set it to 18 FPS and X4. This is what I found to be fairly good, since that's about the rate that I'm running it within my game. And you want to make sure you're extracting to an image sequence, not a video, because we want to make a sprite sheet out of this. So hit interpolate. You let it run for a little bit. For me, it takes, 10 to 15 seconds, and we get this folder out at the end. So I'm just going to rename this to the interp that the sprite sheet expects. And then the last key thing to remember is, since we added this at the end, we need to take that last image and just delete it. The other thing that we need to do is make an idle folder. And we need to go into each one, and we need to grab the last iteration's idle and throw it into here. So that's for the back run, we have the front run, and the side run. We grab these last images, and I'm going to rename them to idle 0, idle 1, and idle 2, just so that they line up the way that I want on the sprite sheet, because the sprite sheet will just use the name order. And now I just need to repeat this for the other 2 animations. Now I have everything set up. I have my 3 interpolated folders with the last images removed. So those are 80 images per folder here. Since we started with 20 and we did a 4x interpolation. And then we have our idle folder here, and this all lines up in our spritesheet.py. So I can just start Python spritesheet.py. And this is going to go through and it's going to extract the background for each one and then splice them all together. Now, since we have 163 images in this, or 183 images in this specific run, it's going to take a little while to run, so I'm just going to let this go through and slowly do all of these, and then I will integrate them into the engine. I got into the game, and as you probably saw from the intro, this is what the result was like. And it's not perfect. There's a few things with it, but I think for given the work, this is, a lot more than one could expect from basically what's 4 images coming into a 243 sprite sheet. So I hope you enjoyed the video. If you did, leave a like or a comment, and maybe subscribe, and I'll catch you in the next one.